reciprocity theorem for antennas. So you have already studied about antennas in electrical signals. So what does it state is actually when two antennas are being connected. Say for example, this is your antenna A. Here I have antenna B. The energy flow is from antenna A to antenna B. Then the reciprocity theorem, since it holds good for antennas too, what does it state is if antenna A produces an EMF of, say, let us say for example VA, producing current IA, right? And I have another antenna B having EMF VB and current flowing through it will be IB. Now, so what happens here is the electrical signal reciprocity theorem for electrical signals normally states that ratio of output to input remains the same even when you interchange the input and output. That's what an electrical signal states. Here also, for antennas also, if an EMF produced in VA produces current IB in B, if the energy flow is from A to B, then that is equal to BB produces IA when the energy flow is from B to A, and same amount of current will be produced in A provided same amount of EMF is being applied at terminals of. So that's what a reciprocity theorem for antennas is stated. Now let us see the proof how it holds good for an antenna. Now let us consider a T network connected between antenna A and antenna B. Z1, Z3. Just mentioning it as I1. Total current flowing through the first loop. Since I am first consider the case of energy flow is from A to B, then the total current I1 can be written as, if I am assuming that the energy flow is from antenna A to antenna B, let VA be the potential across this antenna A, IB producing the current IB at antenna B. So if I am short circuiting this one, so I1 can be written as VA by Z1 plus Z2 parallel Z3. That means VA divided by Z1 plus Z2 Z3 by Z2 plus Z3, which in turn I can write it as this Z2 plus Z3 will come up by Z1 Z2 Z1 Z3 plus Z2 Z3. Now I have to find out current flowing through this Z3. That means current flowing through the terminal B, that is IB. So if you look at it, if I am short circuiting this one, what happens is by current division rule, it is equal to IB equals to the total current flowing through this into the current is being divided among Z2 and Z3. So other parallel resistance by sum of the two resistances connected in parallel. So total current What is the other parallel resistance? Z2 divided by sum of the two resistances connected in parallel, Z2 plus Z3. If I substitute the value of I1 over here, what is I1? BA into Z2 plus Z3 by Z1 Z2 Z2 Z3 plus Z3 Z1 into Z2 by Z2 plus Z3. So this will get cancelled with this one, leaving which BA by VA into Z2 divided by Z1 Z2 Z2 Z3 plus Z3 Z1. This is actually your AB. Now from this I can write VA by IB equals to VA by IB equals to, this will come up Z1 Z2 plus Z2 Z3 plus Z3 Z1 whole divided by Z2. Now let us take the second case where the same thing, Z1 Z3, case 2. Let us consider the second case where the power flow is from B to A. This is your antenna A, this is your antenna B. So Z2 is connected between these two. I am once again connecting the same T network across A and B. VB is the potential, IA is the current. Now from this here I am just mentioning it as I2 current flowing through this, and here I am just mentioning it as IA. From this I2 can be written as, since the flow is from B to A, terminal A is short circuited, right, just as in the previous case where terminal B is short circuited. Now current I2 can be written as total current across this network is VB divided by Z3 plus Z1 parallel Z2. When you look from here B to A, so VB into, so once again same thing, Z3 plus Z1 Z2 by Z1 plus Z2 cross multiplying, and what happens is, so Z1 plus Z2 will come up, so Z3 Z1 Z1 Z2 Z2 Z3. Right. Now once again applying current division rule over here, I can write IA equal to I2 into these two, the current is being divided among these two resistances Z2 and Z1. So I2 into Z2 by Z1 plus Z1. I2 into Z2 by Z1 plus Z2. So substituting the value of I2 that we have found out previously as VB by VB into Z1 plus Z2 VB into Z1 plus Z2 divided by Z1 Z2 plus Z2 Z3 plus Z3 Z1 into Z2 by Z1 plus Z2. This will get cancelled with this one, leaving which VB into Z2 by Z1 Z2 Z2 Z3 plus Z1 Z3. From these I can write VB by IA equal to Z2 divided by Z2 Z1 plus Z1 Z3 plus Z2 Z3 whole divided by Z2. So this term will go up, this term will come up. So VB by I. If look at the right hand sides of both these equations, both are one and the same, right? So obviously left hand sides must be equal. VA by IB equal to VB by I. That means, so if VA produces IB and VB produces IA, if VA and VB are equal, then which produces the currents IB and IA are also equal, right? That's what reciprocity theorem states, right? If an EMF at one terminal produces the current in another terminal, if the same amount of EMF is being applied, then the same amount of current will be developed across the another terminal.